We are set.
Okay. Hi everyone, it's great to be here. So I'm really excited to talk about this topic of chaos engineering. Also, since Litmus 2.0 just launched recently, so I'm also going to, like me and my teammate, we are also going to show you the different features that are coming as a part of this 2.0, and also how these features simplify your journey while you do chaos engineering. So to start off with, I'd like Saranya to introduce herself.
Yeah. Hi everyone. So since I've already mentioned, I work as a software engineer at Chaos Native, and I've been contributing to Litmus Chaos for like more than a year, and it's been a great journey. And I basically like primarily work on the support, multi-tenancy support, and the GUI. So yeah, that's me. Thank you.
Okay, so like I also introduced myself at the beginning, I'm a software engineer at Chaos Native, and Chaos Native is the company that provides support for Litmus. And I've also been working in this Litmus project for over a year, and I've been contributing since 1.x, so like 1.13 and all came, and then 2.0 came into the picture. So yeah, I've been working in this team, and it's been a really great journey so far. Now, the agenda for today's talk would be we'll be discussing chaos engineering just to get a refresher about what it is. Then we'll be talking about Litmus, what is the journey of Litmus, then the advantages that 2.0 bring into the plate, the architecture of this entire flow, this entire Litmus chaos project, the new things that we brought as a part of 2.0, and the core components of Litmus. Then we'll talk about the roadmap and how you can contribute and get started. Oh, sorry about the words. Okay, so to start off with, what is exactly resilience? How do you define resilience? Now, basically, resilience would be a way for a system to sustain a certain fault and bring itself back. So let's say you have a system which, when you induce certain faults or it just goes down for certain reasons, your system should be resilient enough that it can stand back up. So that is the definition of how you would say resilience works. Now, what can be the few cases of resilience? These are the three ones. And this is like for Kubernetes specifically. So let's say you have a pod and the pod gets evicted from a node. What is the state of the pod? Is it healthy or is it unhealthy? What happens if the pod is evicted? Does it come back up? And if it does, then it is definitely healthy. So what happens from the period when it is unhealthy to back again to healthy? So that journey itself, we would call it resilience if it turns from unhealthy to healthy and you do not have to do anything and the system could manage it itself. The same goes for node or memory leak. Now moving on, what is downtimes and how it can affect your system? So downtimes are also something that is related to resilience. Now we all hate downtimes, specifically for the reasons of cost management. Now, cost not in terms of money itself, but in terms of productivity or in terms of resources or usage. So it's very costly when we hit a certain downtimes, and you can see certain examples on the screen as well. So this is like for companies like Apple or Delta Airlines or Facebook. They have all incurred cost in terms of money and also cost in terms of productivity, users, and who knows how many users they might have lost in that particular downtime. So we definitely want to avoid downtimes at all costs. And one way of doing that is entering into the practice of chaos engineering. Now, what is chaos engineering? Chaos engineering is basically the process of testing a distributed computer system, or you can test anything, that doesn't really matter. But it's typically known as testing things in production and actually breaking things in production. But that doesn't really hold good in all situations, because you can test it in any scenario, not just in production. If you have a cluster set up or lying anywhere, it might not be a production cluster, then you can do chaos engineering there. If you have a dev cluster, you can do chaos engineering there. So it's not necessarily in production, you can do it anywhere. And also with Litmus 2.0, you can do it in let's say CI pipelines and a lot of other places, even in CD testing and those things. So it's typically not exactly quote unquote stuck with production, but it's pretty flexible. Now, the goal of this entire process of chaos engineering is to identify weakness in your system through controlled experiments. So you as an architect would control what kind of experiments or what kind of faults you want. In that case, let's say I gave you the example of node or memory leak. So you might want to specifically isolate that part of your application, inject a memory leak or a pod delete or pod eviction or something like that, and as an architect, you would be in control of what exactly you want your system to happen, and you will check if the system is coming back or not after the chaos. So that way you'll ensure that your system is resilient or not. Now, why is it typically required? Why do we do this kind of resilience engineering? Now, if you take a look at this pyramid, you'll see that there are multiple layers. And to be honest, the platform service or the infrastructure layer is actually at the base of it, at the bottom of it. And if any faults occur in the base, all the above layers are automatically, faulty. That's a given. So you can see Kubernetes services run on top of your infrastructure, and then we have the cloud native services like Prometheus or CodeDNS and those things. And on top of that, we might run certain, databases, certain applications like Kafka, databases like Mongo, Postgres. So, and sitting on top of this is your application. So if a certain fault happens in your application, then the other layer below it isn't affected. But let's say something happens in the cloud native layer, then a lot of the other microservices that are connected or a part of that pyramid itself on the top would be also affected. So we do want to test more cloud native components and target the infrastructure more, so that we have a pretty resilient pyramid when it comes to this dependency tree. Now, what has been happening till now? We have this DevOps loop, obviously, but we are practicing more testing on the dev side, and we are not seeing that much activity on the ops side. So with Chaos Engineering, we actually took the liberty to test more into the ops side, because that is the aim for SREs or for DevOps personas, to start testing your application more on the ops side, because you might be very confident that I have done integration into tests, smoke tests, and all kind of testing are already there in my system, and I'm pretty confident it's pretty resilient. But what happens if there's a network loss in your system? That does not, your E2E test would not cover that. So you need to focus more on the ops as well, and dev as well. So with this, also with Litmus 2.0, you get a pretty flexible testing scenario where you can test both dev and ops as well. So that is also something that has been coming up as a part of this 2.0 release. So with that said, how we practice chaos engineering, what are the 4 steps, or what are the step-by-step process of actually doing this? So we have these 4 steps, which are the typical cases of chaos engineering. So it starts with steady state, which is step 1. And steady state is something that you consider to be steady. So it can be anything. Let's say there's an application that is healthy, and it is connecting, or it is doing a certain transaction to your let's say SQL database. So the successful transaction to your database might be a steady state for you. For someone who's curating a different scenario, maybe steady state, maybe it can be, I am doing a transaction but it's failing and I want it to fail. So that is a steady state for that certain persona. So you have to define what is your steady state. So in this case, I'm going to just consider a transaction from a pod or your application to MySQL, and that is a steady state. And now the hypothesis. What is a hypothesis? It's basically, this is where we will think about the scenario that we want to do. So in this case, I want to lose my connection between my application and database, and that would disrupt the connection, and that is something that I want to do. So that is the hypothesis. Now the experiment is the actual pod network loss or pod network corruption or packet corruption or something. And the adapt is, once I do that kind of a flaw, is my database and application resilient enough to gather that connection back? So that is my application adapting and getting it back to the steady state. So this is the entire loop that happens when we talk about chaos engineering. Now this is a detailed architecture of the same thing. Now let's say we identify the steady state conditions. We introduce the fault, which is the pod network loss in this example. Now we check if the steady state conditions are retained or not after the fault has been induced. So is my database and application connected back again after the fault? If yes, it is resilient, then you're good to go. Just go back to identifying your steady condition, steady state condition, and try a different scenario. If not, you have found a certain weakness in your application, and you would have to fix it so that your application is resilient. And if something like this happens in production, you are covered. So that is how the entire flow of the application or the chaos engineering practice happens. Now, the state of chaos engineering currently is, we have the 6 states which are pretty typical that we are seeing these days, which one is game days. Of course, companies practice these kind of game days, which are like sort of fire drills or scheduled time for engineers to just manually induce chaos without them intentionally knowing that they are breaking the system and not happening, not going astray or doing it, by mistake. So this is an intentional planned chaos that engineers do. And also chaos is not really integrated in the CI/CD system, which is a limitation for developers, because a lot of developers do use CI/CD. So if given the chance that we could do it in CI/CD, would be much better. Also, it's targeted mostly for the SRE persona, since they are the ones that look over the architecture and everything, and developers are not really the focus. So that is one thing that was missing, which Litmus also brings into the plate, that they focus on all the personas. And mostly it was manual planning and execution, and there was no automation, which is something that we as developers like the most, automation. So we would like a certain way that our chaos, YAMLs and everything in the Kubernetes architecture, the space, we do not have to manually write everything, and it's auto created based on the choices that we make, which wasn't there previously, which is now there. And chaos observability is not really a commodity, and we as engineers have to set up observability and have to integrate observability with the application that we're using, and it doesn't come pre-packaged as a commodity, which is also something that is missing. And then resilience measurement. So we can have certain measurements of our resilience. It can be anything, but it doesn't come pre-packaged with us. We have to do our custom process of measurement. We might write some script or shell script or something that picks up certain metrics, and we then automate that to get the certain metrics that we want as to be a part of that resilience goal. Let's say in this case, the database connection was lost. So we'll be extracting data from that experiment, and we'll be picking out certain metrics, that what was the percentage of the packet loss or something, and then based on that we have to manually do some calculation. So that is a bummer, and we do not want that. So with Litmus, we have the option to have a pre-packaged this resilience score generation and analytics as well. So that is a pretty good feature. And now let's jump into what exactly is Litmus and how the 2.0 features are useful. So to start off with this project itself, Litmus is open source. Obviously, everyone is welcome to contribute, and it's also cloud native, and it's previously started as a toolkit. Now it's a complete framework, because you can pick up individual APIs as well, and then you can use certain API if you're looking for that itself, and you do not want to explore the whole product. You can just pick out the chaos injection API, and you can just use it in your system. So that's also something that is there with the 2.0. And also it has cross cloud support. So what I mean by that is, let's say you install this product on AWS, you can have your application running on GCP, and you can use chaos on GCP while this product sits on AWS, and vice versa. And there's a list of platform supports that we have. Currently, AWS, Azure, GCP are easily supported, so that's out of the question. And it's also a CNCF sandbox project as of now, and it targets both Kubernetes SREs developers and other personas as well. And we have both Kubernetes specific as well as non-Kubernetes experiment. So we do not even have to have a certain agent or something subscriber sitting on the vendor to inject chaos on the vendor. As in, if you want to delete an EC2 instance, you do not need something sitting on our AWS to delete the EC2 instance. So that is also a part of this framework. Now, certain stats about the project. Currently, we have 50 plus chaos experiments, which is a pretty high number of chaos experiments, and all of them are customizable, so you can tune them according to your preferences. And also, there's a 4 lakh something experiment run, 170,000 installation plus installation, and some GitHub stars and Slack members. But to generally talk about which environments can you target or use these, this typical scenario, like I said, it's for both the SREs and developers. So you can use this in the dev CI/CD pipeline. You can use it in long running tests, which are generally series, or you can have a maybe a custom GitHub what do you call it, hook or something in the PR or command, and where you can inject chaos when you just trigger that particular GitHub action or something. You can definitely do that. We have integrations with Spinnaker, GitHub, GitLab, so that is kept in. So that is also covered. And then you can use staging, pre-production and production clusters as well. What I mean by that is you necessarily not need a production, need to break things in production. You can break things in staging and pre-production or a dev cluster if you want optimum maximum security of nothing breaking or affecting your systems. So with that said, there's the comparison of 1.x and 2.0. What was the change? What is new? Now, previously we had Chaos Hub. It was open source, obviously, from the day one itself, and then creation of CRDs. We had operator schedulers, and we had to inject chaos individually. Why I mean, we had to do individual experiment chaos injections one by one, and we did not have a certain way of wrapping all the experiments and making them up into a single workflow, which we currently support. So you can have multiple experiments joined together sequentially or parallelly, does not really matter. You have the flexibility to change that as well, but it's all mushed up together into a single workflow, and you can just apply the workflow. Also, previously used to do things with operator. So to install the Litmus operator and then inject through that operator. Currently, you do not need that. We have a chaos center, which is the central management hub of everything, and that certainly I will be talking about more. So with the help of that, we can do all sort of things. You can do a lot of workflow management. And we have user management and teaming as well. So multi-tenancy is also there. You can create multiple users. You can assign role based on the users, and you have monitoring and observability integrated with Litmus. So that means when you install Litmus, Prometheus and Grafana comes pre-packaged with the installation, and you just need to add a certain monitoring namespace and do a little bit of configuration, just like 2 commands. But yeah, with that you have Grafana and Prometheus set, and Grafana also comes up with 4 custom built-in dashboards, which is like microservice application dashboard, some node and pod level chaos metrics, and 2 others. Sorry about that. So then also we can manage workflows using GitOps, and we can also add our custom images from our private Docker Hub. So that is another feature. And then we have resilience score calculation. So when we do our chaos experiments or workflows, the resilience score would also be calculated as a part of that. So that is the new features, some of the new features. Certainly I will be talking about them in details and more. And so these are the same things, the advantages of 2.0, but written down in certain bullet points. And we have been doing this over a monthly releases and a lot of community engagement as well. Now, to talk about the architecture of the entire product, what we have is, let's just start from the left. We have the persona, the SRE developer or QA, whoever is trying to do chaos engineering. So we have this application, which is a microservice. This is like a microservice application, but we're considering WordPress as the application which is trying to target or contact with MySQL and do a transaction. And we are, in this case, we are doing a pod network latency experiment. So this is a scenario that we want to inject, or we want to do. This is the hypothesis that we created. And a steady state in this case is our application running fine. It's running perfectly and able to do transactions in MySQL database. So there's something called Litmus Center. Currently, it's called Chaos Center, which is the main a body of everything that happens. The workflow management is done through here. So this consists of 3 components, which is the authentication server, MongoDB, and GraphQL. Authentication actually helps you do the multi-tenancy, and also a smooth onboarding. GraphQL server helps you, expose the APIs and do all kind of connections, WebSocket connections, subscriber, and everything. And also Mongo stores all the events that happens in the chaos execution. So this is what we call as the chaos control plane, and on the right side we have something called as the chaos execution plane. And this is where the main activity happens, which is we have a chaos agent sitting there, and chaos agent is actually something that is a target cluster, which certainly I will also talk about in detail. So chaos agent is basically, in short, you want to target something sitting on GCP, you have to install your agent on GCP. You want to target something on Azure, you have to have the agent sitting on Azure. So it's like a agent that you can install either cluster wide or in a certain namespace. And if your application is running on a certain namespace in the entire cluster, you install this in a cluster wide permission. You can easily target all the namespaces. But if you want to target a specific namespace, you install this in namespace mode, and then you can target only that particular application in the particular namespace. So that is the gist of it. And then we wrap our applications, our workflows in Argo. So we have the Argo workflow controller. We have some event trackers, which helps in GitOps, and then we have chaos monitoring with Prometheus. So that is it. And we have just 2 different CR that I'd like to talk about, which is the Chaos Experiment CR and the Chaos Engine CR. The experiment is the boilerplate template of the entire experiment. So in this case, for network latency, all the tunables and everything that we have, the base boilerplate metadata of the experiment are pulled in from a place called Chaos Hub, which I'll talk about just after this. So that is where we have the boilerplate data of the experiment, and Chaos Engine CR is where we tune those. So let's say we want to change the seconds, number of seconds that we want the workflow to run, we can change it with the help of Chaos Engine CR. We want to change the instance ID or the name of the experiment or anything, any kind of tunables will be done via the Chaos Engine CR. And Chaos Operator is something that keeps a watch and does a lot of validations, as in we want to target a certain cluster. Is the cluster present in your system? Whatever you're targeting, is it there or not? Whatever the tunables you've given, is it valid or not? So these kind of validations are done by Chaos Operator, and it's basically the heart of the entire system. And with Litmus, we can target bare metals, Kubernetes, not Kubernetes, and also VMs, like you can see VMware at the top as well. So with that, I'll conclude with just one thing, that is Chaos Hub. This is like a central repository of all the experiments that we have as of now, which are, this is 49, this is not the latest. If I go to master, this could be more. But yeah, so we have a lot of experiments. We have application specific experiment, we have pod experiment, we have node level experiments, and you can explore all these experiments if you go to this hub.litmuschaos.io. I'll be sharing the links as well in the chat in a few minutes. But yeah, if you just go to this, you'll find a lot of experiments, and some of them are also tagged as infra. Basically, these are infra level chaos, and if you run this, your infra might be affected. You would be affected, not might. So that's why it's like a warning that if you run this, your infra would be affected. So be warned. And like, let's say if you click on this, you'll get a lot of details about this, and you can individually see the experiment CR, see the engine CR and everything. So that's about it for the presentation from my side. Sanya will be talking more about the advantages, the different features that it brings into the picture, and hopefully a demo. So take it away.
Okay, so I'll go ahead and share my screen. So I hope my screen is visible.
Yes.
Yeah, so hey everybody, and I'll be taking you through all the features of Litmus and the core components. So Litmus at its core, we have two major components, that is the Chaos Center and Chaos Agent. So the Chaos Center is basically a single source of truth where it is used to manage, where you can control and manage all the chaos activities, such as you can construct the workflows, you can schedule them, you can analyze them using the observability, then you can also achieve multi-tenancy. So all these features, all these activities can be managed and controlled with the Chaos Center. Then coming to Chaos Agent. Chaos Agent is basically like a target cluster where you would be injecting all the in which the target applications will be there, and you will be injecting chaos to that. So let's say you have a certain number of applications, and they are sitting in a certain cluster, cluster B, and Chaos Center is sitting at cluster A. So what happens is the Chaos Agent will be installed in cluster B, and that particular cluster will become the target cluster, and we can inject chaos to all the applications present there. So uh, like I'll just go ahead and show. Yeah. So this is the Chaos Center that I just talked about. And in my setup, I am running Litmus. I have installed Litmus in Azure. So by default, on the installation of Litmus, a self agent gets created on that in the same cluster, and I can I can induce chaos experiments to all the applications running on the same cluster. So you can also connect a multiple number of agents. So you can just go ahead and follow the steps to connect external cluster. You can have a lot of many number of cluster connect the agents. So that's about the Chaos Agent and Chaos Center. And let's take you to the features of Litmus. So starting off with Chaos Center, the first point is creation of chaos workflows. So chaos workflow basically contains a several number of chaos experiments, which you can club them together either sequentially or parallelly or a combination of both. Like it is based upon your own requirements. So you can club them together and inject the chaos. So that creation of workflows can be done in multiple ways, starting off with creation of templates. So let's say if you have a certain workflow in your mind and that is not present currently, so you can just create the template, save it, and you can use it again and again in the future. Then you can also create some custom workflows by selecting some experiments, n number of experiments from the chaos hub that Shana's already talked about, the chaos hub. And you can also have your own public, like your public or private chaos hub. You can select experiments from there also. Then we do have some pre-created YAMLs. These are basically predefined workflows. So here in this case, the target application will also get installed along with the chaos experiments. So the good thing here is you do not have to do any initial setup, additional setup for the application installation. The application will get installed along with the experiments. Then the third point is control over experiment editing. As I have already mentioned, you can club the experiments in a particular workflow in any sequence. Like you can do it sequentially, you can do it parallelly, or a combination. So you have the complete control over how you want to run a particular workflow. Then you can also schedule a workflow as a singular run or a recurring workflow. So recurring workflow are basically the cron workflow. You can basically have a cron workflow as well. Then coming to the last point here is control over experiment priority. So you have the control. So like you can basically add weights to each of the experiments that each of the experiments of a particular workflow. So like higher is the weight, like the value of weight that you have provided for a certain experiment, higher is the priority. So the advantage here is, like, let's say you provided us lesser value, lesser weight to a particular experiment in a workflow. So in the end, when the after the chaos injection is complete, when the resilience score is calculated, that particular experiment won't affect the resilience score much. So yeah, that's about the chaos center. Then coming to workflow management, you can, like, first of all, we have the automated changes using GitOps. So I'll be talking about this section a little later. So coming to the second point, that is the custom image addition. So you can add your own custom image from your own custom image server, that can be either public or private. And then you can measure and analyze all the workflow runs, the resilience score. We do have the observability section, separate sections where you can analyze and take a closer look how and why did that particular event happen and all. So we also have a concept of probes. So probes are basically the pluggable checks which can be induced along with the workflow. So like, let's say you want to have a particular check, add a particular check to application. So post chaos injection, you can verify whether that particular check got passed or not. So that can be done using the probes. So currently we have four kinds of probes, that is HTTP probe, CMD probe, KTS probe, and PromQL probe. So let's say HTTP probe, like you can check if the particular endpoint is now accessible or not. You can verify that using the HTTP probe. So something like that. Then coming to multi-tenancy. So this is one of the features that also came into picture with the latest release. So you can basically you can be a part of several projects and also create your own team, and then invite other users to your team and grant them access based upon your certain roles. So that brings us to the third point, that is the role based access control. So basically on in portal, like in project level, we have three roles. That is, the first one is owner. So owner is the one who creates the project, and it has, like, he or she has all kinds of access to that project, and he or she can invite other users to its project, like as editor or viewer. So these are the other two roles. As an editor, you can schedule or manage any workflow, and then you can also visualize them. But as a viewer, you won't be able to schedule any workflow, but you can obviously visualize them, or like from the observability section you can analyze how did it happen and all. So you have that. And we have one more level of we have portal level access as well. So here there is one admin and user. So admin, like the admin gets created when the Litmus is installed and the project is created. So admin is the one who has the highest level of like access. He or she is the one who creates other users, and then they can like create their own project and get started. Then we do have the authentication. So that means you have the security, and we have the like the onboarding process is quite smooth. So you can also skip that if you want. Then it's also like it also supports cluster and namespace scope. So let's say if the Litmus is installed in cluster scope, it would have access to all the namespaces in that cluster. But if it is like installed in namespace scope, it would have access to that particular namespace only. So that's that. Then coming to monitoring and observability. So you can definitely connect a data source. You can definitely collect a data source and like monitor the workflows. You can also visualize each of the workflow runs of a like certain workflow. It can be like the workflow can either be singular or like a cron workflow as well. So you can visualize each of the runs of that particular workflow. Then you can also compare two or more workflows. Then post comparison, you can also download a PDF report, and then you can also share it with your team. then uh, then coming to like you can also upload your own dashboards. So like in case you do not like the interleaved one, you can upload your own dashboard, that maybe like the Grafana dashboard. And there are also a lot of dashboards available by the community. You can also download them and upload the same. Then coming to the fifth point, that is you can also tune the dashboards. You can like edit or change the Prometheus endpoints, or like edit the queries as well. And definitely you can like monitor the effect of chaos in the application in real time. So that like is supported too. Then coming to GitOps. So GitOps for chaos. So this is the section which I was talking about earlier. So with GitOps, like you can also integrate it, or like the Litmus also integrates Git based any Git based HCM, that is the like source control manager, as a like it acts as a like single source of truth, and provided that you have enabled GitOps. So once the GitOps is enabled, once it is enabled, like the it switches off the Mongo database. So now you will be like you'll be using Git as a DB. That means like you can manage workflows and all the events via Git as a single source of truth. So like it is also bidirectional in nature, which means if any changes happen to like if you do anything to either Git or the Chaos Center, both of them will be in sync. So that means like for let's say you make some changes in the Git, so it will cause a like rerun of the workflow, Chaos workflow. Then which brings us to this like second point, that is the event triggered chaos injection. So event triggered chaos injection basically like automatically launches the subscribed chaos workflows upon like if let's say your like the target application gets upgraded. If any this is just an example that the upgradation you can, if any changes happen to the target application, it will basically trigger the chaos workflow, and which can like inject automatically. Then coming to the like last point, that is the non-Kubernetes based chaos. So with the latest Litmus 2.0, we do have support for non-Kubernetes chaos. So by that we mean like you can inject chaos to bare metals and some infra resources by like it does by like taking the secrets, that is like the IAM policies and all. So they're taking the secrets, and it will be able to inject chaos in the infra resources that might be running on any cloud provider such as AWS, GCP, Microsoft Azure, or like etc. So yeah, so as a summary, in 2.0 we have chaos workflows. Earlier we just have the experiments, so now you can just club multiple experiments and run as a single workflow. Then previously it was just per user. Now we have the support of teams, like you can invite other users and then can work collaboratively in a single like in a particular project. Then it was like earlier it was just per cluster, now it is per organization. So this has been like uh, possible because of the like due to the concept of like the agents. So, and then in 1.x it was just like Litmus just supported public Chaos Hub, and then we right now we have support for like both public and private Chaos Hubs. Then earlier it was just CLI only. Now we have both CLI and GUI. Along with all those features, we do have a lot of additional features such as like GitOps, scalability and high availability, then integrated and interleave monitoring, etc. So jumping on to the demo, just as I'm like, as I've already mentioned, I am running Litmus on Azure. So these are the components. You can see the event tracker, the sub front end, like front end, the server and all, so Mongo. So these are all the pods that are running. And yeah, okay, so this is the chaos center that I have already talked about. So upon like I have, in this case I have logged in as admin. So once like upon successful onboarding of like, if you log in for the first time, a default project gets created for you. For in this case it is admin's project. As you can see here, he or she is the owner. So yeah, so here if you are part of any other project, it will get listed out here. And this is the chaos agent that I've already mentioned. This is the self agent, the target agent. In my case, I haven't connected any external agent. So this is the, like, this is where I'll be like targeting, like inducing chaos. Then we have the chaos hub. This is the Litmus chaos hub. Here we have the yeah, these are the predefined workflows, the pre-created YAMLs that I had talked about earlier. And this is the chaos charts. So this contains all the experiments like which just Shine had just showed you in the like hub.litmuschaos.io. So all of these experiments are embedded here, and you can just take a look and pick any of them for custom workflow creation. Then coming to the Litmus workflows, here in the like run section, all the workflow runs that are like have run before or are currently running will be listed here. And this is where all the schedules, if you have scheduled any workflow, it will get listed here. So like I'll just go ahead and schedule a workflow. So as I've already mentioned, I have just the self agent, so I'll choose the like target agent as my self agent. Then I'll just click on next. Yeah, so these are the multiple ways of workflow creation that I mentioned earlier. So first one is you can select any pre-created YAML or the like predefined workflows. The second option is by like using a template. Currently, I do not have any template. So like if you have, you can just add it here. Then this is like for a custom workflow creation, you can like choose the workflows, choose the hub first, chaos hub first. So since I haven't connected the chaos hub, so by default the Litmus chaos hub will be available. Then you can also import any workflow YAML if you do have. And okay, I just forgot to mention the chaos hubs. Okay, I can also connect the like new hub. So let's say if you have any repo, git repo, which you want to connect as your own hub, so you can just provide a hub name and the git URL and branch. In case of public, you can just provide and connect your hub. You can also have the private chaos hub here. So here you can just provide the URL and like access token, or you can do it via SSH and then you can get connected. So I'll just leave it for now. I'll go ahead and schedule the same workflow. Okay, so I'll just go with the first option, that is the pre-created YAMLs. I'll just select the Potato Head application. So Potato Head chaos. So the Potato Head application is basically a CNCF microservices demo application basically. So I'll just go ahead and show you. Yeah. So here, this is the like Potato application. Here, as you can see, each of the parts, the like left leg, right leg, the arms, the heads. So each of these parts are like a single microservice. So we'll be targeting chaos on these, like inducing chaos on these like microservices. And in this yeah, in this workflow, we are doing the pod delete, like we're using the pod delete chaos experiment. Okay, so I'll just select that and click on next. So here, as you can see, this is the workflow name, the description. You can also edit if you want, and I'll leave it as it is. Then this is the yeah, here as you can see, this is the very like a rough visualization of how your workflow will be running. So first of all, the application will be installed. In this case, the Potato application will get installed. So once the installation is complete, the experiments will get installed. In that case, in this case, like we have the pod delete here, pod delete experiment. So here the chaos injection will take place. Then after the chaos injection is complete, these two steps, the revert chaos and delete application, these two steps will be running in parallel. So a revert chaos basically cleans up all the resources that got like created during the chaos injection. So it will clean up, gracefully clean up all those resources, and delete application will basically delete the application. In this case, it will delete the Potato head application. You can also edit the sequence if you want. Like you can just drag and drop and edit the sequence. In my case, I'll just leave it as it is, and I'll just quickly go ahead and edit, make a minor edit. So this is the workflow YAML. All the specs, all the specifications are added here. So these are, as you can see, this is the steps that I just mentioned in the visualization. You can just install the application, then the chaos experiments, pod delete, revert chaos, and all. I just quickly like change the type name from resilient to weak. This is like, otherwise it will take like a lot of time to like finish the injection. So I just save the changes and click on next. So here you can add weights to the experiments. So like since in this particular workflow we just have the pod delete, you can just add weights. So it adds, like I have mentioned, it decides the priority of each experiment of the particular workflow. So I'll just give it 10 for now, and then I'll just click on next. So you can also schedule, like you can schedule a workflow, like you can schedule it right now, or you can have a recurring schedule that like every hour, every day, every week, and all. So I'll just go ahead and choose the first option, then clicking on next. So this is the summary page, all the settings that like, however, like how do you want to run your like workflow, it is all mentioned here. And just see the weights, the schedule type. It also validates the YAML, if the YAML is fine or not. And still, if you want to do any changes, you can just go back and edit the changes. So I'll just click on finish. Okay, so workflow got created successfully. Now, as you can see, it got listed in under the runs. And if I go ahead and click here, yeah, so as you can see, the workflow is running in this node. In this particular node, it is basically checking if the target like agent is healthy or not, if the application is like or like present or not. So all these checks. Now you can see the application installation is going on. So I have watched. So as you can see, all the like the left arm, head, hat, all of them are getting created. Now they are in running state. So in this application, like in this workflow, we'll be targeting this particular, like the main, even this particular pod for like pod delete, injecting chaos on this particular pod. So yeah, so once the application is complete, like installation is complete, I will just go ahead, show you the application. Okay, it's in pending state. So meanwhile, as you can see, experiments are getting installed now. So if I click on any of the node, you can like get see here all the logs of each node, each step. Here I can see like the logs. Then yeah, now the pod delete is getting installed. Okay, I'll just take the external IP and the port number. Okay, it might take some time. So here, like you would be able to access the Potato main, like the Potato head application. It's taking some time. Okay, so meanwhile, I'll just show this is the chaos injection pod. Like here, the chaos injected. Here, as you can see, the logs are available, and there is one more section that is chaos results. So in chaos, that this section, like the results will only be available in the end. Like once the injection is complete, results will be available. You can get the verdict of the application. Then while the application is getting run, I'll show the other sections as well. This is the settings section. Here under my accounts, you can change your user level details. Then this is the teaming section where you can like invite other users to your project. You can also like change your project name, and you can see the invitation status, the pending any pending invitations, or like any active projects, other active project that you are a part of. And this is the user management section. So this is the part, like this section is only available to the admin user, and admin is the one who can create any user, like any new user, and he or she can manage it. And then we have the GitOps section. So here, as you can see, like by default, it is using like local in Litmus, it is using the Mongo. You can also enable Git by selecting this option. Then we have the image registry here. Then coming, like, let's see what is, okay. Okay, the application is still running, the experiment. Okay. In the tabular view, you can also view all the log, all the details of each of the nodes in the tabular manner. Then, okay. So as you can see, the injection is complete. So it has failed since I have I had changed the type name from weak, like resilient, to weak. The revert chaos, and these two steps also run in parallel. Now, if I click on this node, yeah, so you can now get the chaos results. And if I go back, you can also see the overall resiliency score here. So like this is their overall resiliency score, and the experiment, number of experiment passed and all. You can also go to observability section. Then you can get here all the statistics related to workflows are available here. You can see the run stats, the schedule stats. And if I click on that, the workflow, I can just, you can also, like, if I had any other like more number of workflow, I could have just compare. And I'll just go to this, like this route where I can see the statistics. As you can see, experiment, all the, what are the experiments, the verdict, the weights, and all of these are visible here. And you can also have the graphical interpretation like here. So that's that. As I have already mentioned here, the application got deleted, and yeah, as you can see, this is no more visible. I think it took a lot of time to get loaded, but the application no more visible, like accessible, because the application got deleted. You can also see here the application got deleted, and you can see the main server, potato main server, is no more available. The application also got deleted from the pods. So that's basically like a very short, a brief demo of how easily you can inject chaos. Then coming to uh, yeah, coming to future, okay, yeah, coming to future roadmap. So in future, we have planned to increase the support for non-Kubernetes based chaos, like non-Kubernetes based experiments. Then we also want to have more application specific chaos experiments, so that we can have native faults and health checks, etc. Then we also, like, we would be improvising the chaos SDK, which is used for like creation of user defined experiments. So like improvising this might, we can like make this experience a more like smoother. Then as we currently have four types of probes, I have already mentioned HTTP, KTS, CMD, and like PromQL. So we want to diversify, like we want to add more probe types, and want to diversify the steady state hypothesis validation. Then we want, obviously we want to improvise more and more on observability section for each of the case experiments, the runs. Then we want to have more types of chaos actually. And these are some of the, like, these are something that we are looking forward to. Then coming to contributing guide, so there are a lot of good first issues for, like, for the beginners who can get started, who can just take a look and get started. And we also welcome contribution, not just like just to the main Litmus. We can like you can contribute in all kinds, so like be it development of new features, bug fixes, and like other improvements. You can also take a look at the documentation, and like you can suggest or improvise it. You can also contribute there also. And then these are some of the sub dependent repos, like the charts, workflows, websites, and also you can take a look and get started from here too. Then these are some of the links that we'll be sharing, important link. That this is the repo link, the doc links. And then you can also join us channel, where you can just post your queries if you're getting started, if you're finding anything like difficult, you can just post your queries, and we would be happy to help you there. Okay, so that's all. We hope you found the session productive. Thank you.
Thanks, Aranya and San. Excellent session. People have been asking questions in the chat box, but if anybody has any questions and want to ask, we can just quickly cover that.
Just wanted to pinpoint one thing. I've shared a link to a Katacoda scenario. Now, Katacoda, this particular scenario runs on Minikube running, which is I think their most smallest VM in the cluster they have. So it's pretty fast. So if anyone's willing to try, you can try out this scenario. You do not need any setup. You can just use it in the browser, and whatever you saw, the chaos center and everything will be embedded in the Katacoda dashboard itself.
Okay, cool. Yeah, thanks. I had one question, and a basic question. So what do these app level experiments contain?
This application, oh, okay. So the example that you just saw today was this one, right? The potato head. So we have other experiments like Bank of Anthos or any kind of microservice application, right? So this potato head application is consisting of multiple microservices. So one is, let's say, a left arm, left hand, right hand, left leg, right leg, and those things. So the chaos that we did was we tried to break the potato main, which was the front end. And potato main is like the front end, which is consisting of multiple these sub modules like the leg and arm and the head and hat and everything. So we are picking up these microservices just as an example for users to get started with. So there's Bank of Anthos, which is like a banking microservice application. Then we have a sock shop application, which is like a sock selling application, which has these RabbitMQ, then catalog or a certain database and everything. So we are picking certain microservices out of the entire bunch, and we are like targeting a bot delete, or let's say a catalog delete or something, network loss, packet loss, something. So that way the applications are also installed and users don't have to go through the hassle of installing them, and the chaos is also injected. So that is what the applications contain in your question. This one contained a lot of microservices, and we are targeting the main, which is the front end. So that's why it broke.
Okay, got it. Thanks, Anne. Yep. Any other questions, folks?
I have a question. Let's say when we started running a particular experiment, what kind of metrics it generate regarding, or does it generate a metrics about the start of a particular experiment? Because I'm asking this question. I have my own observability system, which normally observe my whole stack, whatever is there in my cluster. Now I want to have a correlation that, okay, I ran this experiment and this changes in my metrics or this logs that is happening with so many errors now has happened because of this particular experiment that I run during starting this duration and ending this duration. Because that will give me, it's easy to drill down, understand, and have more visibility around that, where it failed and then where it got succeed and how many things it has affected. So in order to do the correlation, what kind of I know you've shown that you have observability dashboard within the Litmus, but what kind of data it generates? Just as a question on that.
Yeah, so good question. There's something called as a node exporter that we have as a microservice, Abhishek. So when you set up monitoring, currently in the setup, we have the interleave dashboard, but we did not set up monitoring in this case. So that's an extra step that you just need to create a namespace monitoring, and then you set up that whatever integrated interleave dashboard, Grafana, Prometheus, and everything. But what happens is when you set that up, there's a microservice called node exporter, which exports all the different kind of metrics that happens when we do chaos. So in this case, you have your own observability setup. So what we have is this chaos result CR that we have, right? That is the result, that is the CR which generates all these kind of metrics. So we have, let's say, an experiment verdict, a probe success %, and also the duration of, the chaos, as in what exactly happened in the duration. And we also export these logs out. So you can also find log. You can also find the success percent and everything from the log itself, and also the chaos results here gives you the probe percent, what exactly happened in the probe. It can tell you that if it failed, why it failed, and if it passed, why it passed, what kind of probe it was, and these kind of stats in terms of metrics. And you can export these metrics out with the help of this node exporter, and you can also integrate them in your own observability setup. So currently Litmus comes pre-packaged with Prometheus and Grafana, but that is not the end of it. You can of course use your own observability if you have. So you just have to take the node exporter out of our cluster, and you can integrate your observability setup with this one.
Okay, so your CR expose certain metrics which we can use. That answered the question. Another question that I had around the area. Sorry, I just slipped. The question slipped from my mind. Sorry, I'll ask after some time, just because something slipped from my mind.
Sure.
Okay. Hi, Sayan and Saranya. Thanks for the great. I just have one question. So, how many experiments can we run parallelly, like pointing to two different agents? And what is the consumption from the central self agent?
Yes. So it might sound weird, but you can run a lot. Actually, that depends on your cluster, but you can run a lot of it. As in, why I'm saying this, because we have done a test where we ran about 1,000 plus agents on our cluster, and that was obviously we had to scale. We had to do a HS setup, but that is number of different kind of agents that we connected. So considering you have one agent and you want to scope it out into a lot of parallel experiments, so it would obviously consume a lot of resources, which would mean you would need a lot of CPU, a lot of memory. So based on how much you are able to scale your cluster, you can run as much parallel experiments as you want. But if you, let's say, have a 16 GB cluster, and you with a 16 GB cluster, I think you'd be pretty good to run 5 to 7 parallel experiments. But let's say you overdo it and you do 12 or 15, then it might break, because your cluster won't be able to handle that much resources. So it would result in a failure, and of course it would either terminate or be in a hanging state, and you have to batch the chaos engine to either stop or you terminate the same. But it depends on your cluster, how much your cluster is able to support. So if you increase your cluster size, you can run a lot of parallel experiments. That is good.
Yeah, thank you.
Let's see one question. Is it
there's one question in chat.
Yeah, it's not a paid tool, it's completely open source. The one that there's another Chaos Native Enterprise, which is a beta thing that we are working on, that works on top of Litmus to provide a lot of extra support. But this one is not a paid tool, this is completely open source and for the community. So
yes, and I was talking about the Gremlin.
Yeah, I was talking about the Gremlin tool, the question which Shakti asked.
Yeah, okay. Pros and cons about Gremlin. Okay, so we have a comparison chart. I guess we can share that, but to say that as of now, okay. So we support non-Kubernetes chaos. I think that is a way to go that we're looking forward to. Another is we do a lot of integrated observability, and what else? That's the two that I can think of right now. We do integrated observability that comes hand in hand. It is and third, yeah, it's open source, so everyone can contribute, and anyone can give in feature requests, and we would be glad to take them and build them. Plus, yeah, the enterprise support that I just talked about. We do this wrapper on top of the open source so that we can focus completely on enterprises. So if a certain enterprise is looking for one requirement, we can completely give them a MSP build, which is like a managed service build. So we can build a wrapper for your enterprise, and we can provide the customers what your enterprise needs. So that is one. And yeah, these are the three that I would consider as a pro.
Hey, Sayan, this is Sunil here.
Yeah.
I have a question. Like, basically, how is the high availability managed for the control plane, pods? So how is it managed? Do you have any HPA, or is it running as a daemon set?
We currently do not do high availability for the control plane. So I mean, based on your cluster, you have to handle your HA. We currently do not support HA, that we do not manage the HA as of now. So when you install this product, it is completely isolated. That means it would give you an air gap support as well. So based on what infra setup you have to currently manage that. We do not actually handle any cluster level, management.
Okay, so you mean to say like we can set up an HPA for that, right? So to ensure that we have more replicas for the control plane at least.
Yeah. Yes.
Right. And just one query regarding to AKS side of things, right? Like as you said, right, we should have each agents, right, running on each particular nodes, right? Now for a AKS cluster, assume like I have around 5 to 6 node pools, right? A user node pool and system node pools. So how this installation will cater that I have an agent on all these node pools? So is it like out of the box?
So when you install it in a cluster, so it is actually installing the entire cluster. So we do scrape it out with the help of an API, and when we just add experiments, we have an option we just call it as a configuration stepper, which is like a wizard, where we have a drop down which actually scrapes all the different labels or deployments or these stateful sets and everything that you're running on your cluster. So you can pick which application you're targeting, whether it's running on wherever in your cluster. So it's discoverable.
Okay. Because I wonder that, like, for example, any one of those your pods would run as a daemon set on each of those particular nodes. Yeah. So.
Yeah. Got it.
All right. Okay. Thank you, Sam.
Yeah, if there are any further questions, I think we should just take them offline because we are running out of time here. But thank you so much, Sayan and Charanya. Very nice session, and I'm sure everybody has found it to be very useful. So yeah, thanks once again. I think before we move to next session, Vishal is back. So Vishal, do you just want to take it over?
Yeah, sure. Cool. Thanks, Nikhil. Cool. Hey, everyone. So I think we have the next Vaibhav Tripathi from Taviska, the PMC. He's going to talk about best practices for Kubernetes clusters in production. So Vaibhav, please, take it away from me.
Yeah, thank you, Vishal. So, okay, all right. So I'm sharing my screen. Let me know once it is visible.
Yep, you can see the deck now. Thanks.
All right. So thank you, Vishal, first of all, for giving this opportunity for sharing this experience of adopting the Kubernetes with the community. And hi, everyone. So today we are going to discuss about a journey that how Taviska adopted Kubernetes, and also while doing that what are some best practices checklists that we had created to measure our production readiness before we go live on Kubernetes. Right. And this is something I feel that anyone who is in the early adopter of Kubernetes or the organization who is planning to move to Kubernetes can use. Right. So quickly jumping on the agenda. So we're going to discuss a brief introduction about what Taviska as a company do. Then what were some uncertainty that we thought that when we thought of adopting Kubernetes. Then how did we approach in solving those using some pillars of architecting, and then the content itself, that what are the checklists that we had created out of it. All right, so a brief introduction about the company. So at Taviska, we build products which basically enables our customers in the loyalty segment. So we have a couple of products which basically offer loyalty programs in travel, in merchandise, in membership, and there are other as well, right? We have around 10 to 20 products offering, and all these products are built using microservices concepts. And the count of microservices that currently we are running on production is around 170 plus. Right. So a brief introduction about what does our cloud journey looks like. Right. So in 2015, we started with our cloud journey, where we started using some Python scripting to host our application were written using .NET application, which can only be hosted on Windows. So we started hosting our application on cloud on Windows servers. It was the first step that we took. We used scripts, Python scripting automation, and then Chef Cookbook for configuring our servers. Then after the evolution of .NET Core in 2016, we started looking at it. And from 2017 onwards, we started adopting it. And this was our first step that we took towards containerization, right? Since we wanted a quick workaround to how we can move our current workload from Windows to Linux, the major objective of doing that was that we wanted to reduce our cost of operation, right? So I'm sure that most of you must be using AWS. So if you compare the cost of a Windows servers and a Linux servers, you will at least see that there is a 50% amount difference between both of them, and even more sometimes if it's Spot instance especially, right? So our motive for using the containerization at that time was that we wanted to move away from Windows and start adopting Linux servers so that we can reduce our cost of operation. So we quickly adopted AWS ECS service, and we were running on containers by 2018 on production, right? Now with launch of EKS, we saw that this is an opportunity where we can it would be a good strategical move for an organization to now adopt Kubernetes, right? Because it offers a lot of features which ECS was not offering then, but now it has matured enough. But yes, still there's a lot of more features that Kubernetes offers. So from the strategical move point of view, we thought that let's now take a stab at and we start moving towards Kubernetes, right? So then we did the discovery, the rollout, and by 2020 early, we were running on production on Kubernetes, right? Now, if we talk about the journey, right? So the journey from moving from the ECS, where we are already containerized, running on Linux, right? And now to move to Kubernetes was full of uncertainty, right? So like I said, the main motive purpose of us moving to a Linux world was to reduce the operation cost. Right now, we were already doing that, right? Now, why one should adopt Kubernetes, right? So there's altogether different topic that we can talk about ECS for the Kubernetes, but I'm not going to touch base on that. But for different strategical reason, we talked to our stakeholders and said that yes, although we are running on ECS, we have performance tuned it, but we can migrate to Kubernetes, right? So in those discussions, we came up with certain condition that it needs to be a zero downtime. The adoption effort should be minimal. There should not be any performance impact. The way we are running in .ECS, it should be the similar way that we should be running on Kubernetes. There should be similar or minimal operation effort, right? So, and the environment should be reliable, secure, and cost optimized, right? Now, the first condition is something that IT industry has been doing for quite a long. The blue-green release process has been there. So it is not something difficult to do, right? But as you read out the condition, it becomes difficult where it talks about that the adoption effort, right? And the effort after you move to Kubernetes should be minimal, right? Or should be less than that, right? So there we thought of that, since it is also our first time that we are taking a stab at Kubernetes, we read around a lot of stuff to kind of create a checklist that one can use to say that, hey, now I'm ready with Kubernetes and I'm good to go live now, right? So to answer all these questions before actually jumping and starting to look at what should be the right solution for it, right? We took a step back and say that, okay, let's do one thing. Let's just find out that what are some benchmarks that we are going to say that we have achieved. Once we are going to say that we are good to go for live, right? So there we read a lot of white papers around what are some pillars of architecting, and personally I like what AWS talks about the pillars of architecting, that they have also created a well-architected framework for that as well, right? So these are the few pillars that we took in consideration while designing our cluster, right? The first one is that our architecture should be, the Kubernetes architecture should be should follow the operational excellence pillar, right? Which essentially means that we should be able to make small releases and reversible releases. All our operation that we are going to perform should be as code, right? Now, the second one, which talks about security, right? So it is something which is essential. So we talked about that how we can secure our parameter, then we move down towards our defense in depth, so that how much secure we can make our castle, right? The second one is the reliability, right? So now we're talking about that we are doing operation as code, we are going to make secure, right? But at the same time, we want to make it reliable for our developer and make it easy for them to use it as well, right? So they should not feel that, hey, I was already doing something, now you moved me to something and my life has suddenly become too complex, right? So there we talked about that it should be reliable enough that we can put some load on it, it should easily scale, it should auto heal, right? And it should be fault tolerant, right? Then the next pillar that we should be covering will be around performance efficiency, right? So we have already established some SLA, while like I said that we had already performance tuned our ECS cluster. Now we are moving towards something new, and we wanted to make sure that we do not compromise in this direction, right? So we need to have a cluster automated enough to auto heal, to auto scale, right? And to provide the right matrices that our team can look through. So say that all my applications are running correctly, right? And the last condition, although we are doing a migration, we still want to be cost optimization, because if we look in terms of business, we are running on Linux, we are still containerized, right? So this solution needs to be a cost optimized as well, right? So looking at this architecture pillar, so we came up with certain matrices, certain barometer, I would say that we are going to test our cluster around, and we searched around different blog posts, different SRE books, so that how we can achieve these things in a Kubernetes cluster, right? So by reading all those through, we created a consolidated checklist, right? So where we talk about that how, if you want to set up for availability, at least these are the conditions that you should follow. If you want to design for the scalability, then these things at least you should consider. Then similarly, security, resource management, monitoring and alerting, right? So before moving ahead, I just want to basically ensure here that this is not a de facto list, that is something which is going to cover all the direction, but this is something that you can use to start and to measure where do you stand currently today, okay? All right, so when we talk about availability, right? So we basically want our application to be highly available as well as fault tolerant when we see any kind of outages in one of our data centers, right? So in terms of AWS, we call it as availability zones, right? So whenever you generally see that, hey, I want to do an HA, so you think that at least that I should be deploying I should be running multiple version of my app, multiple replicas of my application in different data centers or availability zones, right? So this is what we are going to talk about today, right? So while designing for availability, one important thing is that especially in Kubernetes, that whenever you are deploying your application, you should always configure liveness and readiness probes, right? So these probes helps you in making sure that the application that you have just deployed in your cluster is ready to receive traffic, as well as has all the infrastructure or the allied services that it requires to operate with itself, right? So always configure your liveness and readiness probe, right? Now this configuration is with respect to your Kubernetes, right? And the Kubernetes also require the virtual pods that you are running also require some hosts or the servers on which they are going to run. So always distribute our worker nodes across multiple availability zones, right? Configure auto scaling for your worker nodes as well, right? So sometimes people generally miss around that how I should be managing my worker node infrastructure, right? So we always talk about HPA, that how I should be configuring my pods, right? But the important thing to note here is that we should also have an auto scaling configured for our worker node as well, right? Because it may happen that you may launch certain product and you are not receiving good traffic, but you have not configured worker node. So you need to start from very scratch to have the new worker node added into your cluster, right? So always have the provision to have an automation to run to add worker node in runtime, or maybe through some provisioning way if you are running it in data centers, right? Do not spin up any naked pods. So naked pods, it is very difficult to manage the life cycle of a naked pod, right? So when I say naked pod, so running just a kubectl command or maybe a YAML file, just asking Kube API to spin up a single pod, which is not part of any deployment or a stateful set or a replica set, right? So it will be very difficult for us to manage the life cycle of it. So always try to spin up your pod using some kind of Kubernetes objects such as deployment or stateful set, which have a replication controller with them, right? Always have the correct number of pods replica for high availability, right? So it may happen that if a misconfigured deployment YAML can lead you to a downtime, right? So let's say if I created a YAML file which has a deployment, which has a replica set, but I started with one pod. right? And currently I'm not seeing any traffic, or maybe I'm able to suffice whatever traffic I'm get with one pod, right? But the day if your AZ or your node goes down for that pod, you will see the downtime till the time new pod gets spin up, right? So always have the right configuration for your pod replicas whenever you're really, right? The next point is set up an ingress controller for public access, right? So why this is important? So usually people, if you're an early adopter of Kubernetes, what you will try to do to expose any deployment of pod, you'll try to create a service object with an external load balancer, right? And you may end up having a multiple external load balancer. Then to manage their availability and then to manage their configuration will become pain in the future, right? So always have an ingress controller where you can define that for any public public communication happening inside my cluster, right? It should come via my ingress controller, and it is your single point of contact where you can have all the configuration and your security configuration as well as your application control at a single place, right? So this will help you in ensuring your availability. Any questions till now? All right, let's move ahead. So the second point is the scalability, right? So we talked about, we addressed it a bit in the availability section, right? Where we talked about the node scaler, right? Here we are going to specifically talk about what tools we can use to basically achieve scalability. HPA is something that I'm assuming that everyone must be using, right? So always configure your deployments with HPA to listen on certain matrices. You can have your custom matrices as well based on your application. If not, there are default matrices also available in the metric server, such as CPU, memory. We should always use them, and we should always have our deployment configured with an HPA so that you have an auto healing as well as an auto scaling mechanism in place, right? Now, if you're in cloud, you should definitely use cluster autoscaler, because this is something which will help you in auto heal as well as scale your application seamlessly, right? So how does cluster autoscaler works? That let's say that you already have defined YAML with HPA, right? And your manifest file is configured, your deployment is configured with HPA, and there is certain load that you have put on which requires your scaling of your pod. Now, it may happen that the resources as a worker node that we have configured to a Kubernetes cluster, right, it does not have enough space to host that particular pod, right? So what cluster autoscaler does, it reads the event of insufficient resources when there is a pod in pending state. It calls your autoscaling APIs and can add a new node so that to your EKS cluster, so that your provisioning for Kubernetes for your pod can happen seamlessly, right? It comes with a lot of options. You can play around with spot setting as well. If you want to control your cost, you can play around with the prioritization as well. If you want to control the way you want to schedule your pods. So all these things can be possible with cluster autoscaler, right? So always configure it for the cluster autoscaler as well whenever you are deploying your application in Kubernetes on production. All right, moving on, security, right? So this is one of the most important steps that I believe everyone should be following and making sure that this is something that we are doing as part of our first validation whenever we are running whenever we are setting any Kubernetes cluster on production, right? So it's the paramount step that one should perform, right? So what all Kubernetes has to offer in security and what all we can do, right? So the first step that we can do is that always run the latest version of Kubernetes, right? So Kubernetes keep on releasing patches, keep on releasing major upgrades, right? Always listen to them and make sure that we are following a cycle in which we are upgrading a Kubernetes version. Because in those patches and those releases, not only new settings are configured, but security patches are also available, right? So it is essential to be secure, at least on production, where you do not want to end up in a situation where your data center is compromised, right? The second thing what we can do is that enable RBAC, right? So by default, a lot of open access is provided when you install a Kubernetes, right? Always have a role-based access control so that you are able to control that who is accessing what resources, right? So always have that. You can create different namespaces, different product namespaces as well as deployment labels, based on which you can control your roles, with which user is allowed to access which type of controls, and you should be doing that, right? And the third thing is that enable audit logging, right? So most of the time, especially when we are running our cluster on Kubernetes on AWS and using EKS service, right? So we focus more around that, how quickly I can get my application up and running, right? So if you're using control plane or managed control plane, you forget about that. Okay, this is something which is managed by cloud. Now I need to focus on my worker nodes for my availability, for my scalability, right? And I should just focus on around that, how I should be deploying my application, right? And how I should be managing my resources, which I am governing on cloud, right? But again, so the people, the company or the vendor you have chosen for managing your control plane, right? They also sometimes can mess up, right? So you should always have this audit logs enabled to check what exactly happened behind the scene, to check if there was an issue with your application not being bootstrapping or not being getting up, or if you're seeing something, some intermittent error. It can be a network jitter, but sometimes it can happen that your application has not scaled or your control plane has not scaled up, right? And with AWS EKS, we have faced it a lot of time, right? So if you are putting a spike on EKS from X to 5X load in hours of time, you will see certain intermittent failures, right? So when we saw the logs, we found out that our master plane was not scaling with the speed where we were scaling our worker nodes, right? So when we spoke to them, we found out that we always have to raise such kind of request to AWS, inform that about your pre-scaling stuff, that, hey, I'm going to do a performance run and I'm going to put a load of X to 10X in an hour, right? So that they have their team behind the scene working on scaling it up as well. So it is not as smooth as we think, right? So always have your audit log enabled, so that you can find out what is happening in your control plane, right? You will be setting up something to find out what is happening in your data plane, right? But audit log is something for the control planes is also essential, right? Then moving on, enable always pull images in admission control, right? So sometimes people may ask that, why is it something that I always pull images when I already have a replica of it running in certain other namespaces, right? Maybe I'm using a layered Docker images, right? So which is being where the Docker image is being created on top of another Docker image, right? So why I always go and call the same Docker image when I already have something in the cluster, right? Now, this is something important when you are running your application or your Kubernetes cluster in a multi-tenant setup, right? So for example, here at Taviska, I talked about that we have around 10 to 20 products across different domains, right? So, and I also talked about that all these products are following microservice architecture and are written in .NET Core, right? So being a single one company, we share a lot of stuff. We share golden images. We share a lot of practices as well, right? But ultimately, to manage a unique lifecycle of every product, it is not possible if we are going to have a sharing model enabled across namespaces, where I'm saying that, hey, if product 1 has already pulled that image, product 2 don't have to do it. You just take the image from the Kubernetes cluster and run it, right? So I will not be able to put control, right? So if in the settings that if, let's say, if somehow product 1 developer messed up with the product 2 can see a downtime, right? So always have a pull images to, and now when you're going to have this always pull images, you're going to ensure that the proper credentials are passed to your YAMLs, to your pods, whenever to your Kubernetes worker nodes, when the kubelet is trying to pull the images, right? So always have that, and always have this control enabled, so that you can run a multi-tenant model in your Kubernetes cluster, right? The next point, and I feel this is the important point, where how a network plugin plays an important role, right? So I feel that right now that a lot of people whom I meet to talk about that how you are running your Kubernetes cluster, generally, I see that a lot of them are running in a multi-tenant model, which essentially means that we are creating a logical separation for our tenants, but not a physical separation. For example, so for tenant 1, I'm not creating a different Kubernetes cluster with different set of worker node, and for tenant 2, I'm creating a different one, right? So what we generally try to do is that we try to create segregate the different tenants on the basis of namespaces, on the basis of deployments, right? And a lot of other configuration. A network plugin enables you to define network policies, right? So it may happen that you have different products or different tenants, and one of the namespace wants to access, let's say we have 3 namespaces, namespace A, B, and C, right? You want an application in namespace A to call namespace B, right? But you do not want it to be a vice versa, that a namespace B application can call namespace A, right? So if you do not have network policy enabled, by default, it is all open. You can do a two-way communication, right? But with network policy, you can have a more stringent firewall rules, more stringent network rules to control your traffic flow inside the Kubernetes cluster, right? The other advantage that I would suggest of using a network plugin with an overlay network would be that whenever we spin up a pod in Kubernetes, it takes an IP from the virtual network that we put it inside, right? Specifically talking about EKS and AWS, right? So if you are running your Kubernetes cluster in AWS in EKS and using EKS, the pod running inside your worker node will always get the IP from your, by default, it gets the IP from your VPC CIDR, right? And it's not like that in AWS, at least, that as soon as that the number that you will always see the number of pods that you're running in your EC2 instance, you will have the same number of IP attached to it, right? So that's not the case. So even if the EC2 instance supports, let's say 20 IPs and you're running just 2 pods, right? The EC2 instance will take the 20 IPs from your VPC CIDR, and this is going to increase exponentially as you grow, right? If you're having a high ability setup, a fault tolerance setup, and you're doing performance run, right? And as soon as you're scaling it, you will see that your IPs will start exponentially depleting from your VPC CIDR. And if you're using any other services apart from running just Kubernetes, you will find a short of IP. So a good practice would be to have an overlay network setup, right? Maybe we can use Flannel if you don't want to use AWS VPC overlay network. But if you want to use still stick to that, I'm using cloud, so I don't want to set up anything on my own, specifically networking to deal in with the network issue when I whenever I have trouble with it, right? I still want to use AWS VPC. Then please make sure that you're using a secondary CIDR attached to your AWS VPC, right? So which will help you that all the pods which are spinning up in your Kubernetes cluster are getting the IPs from your secondary CIDR, but your primary CIDR is still available, which you can use to do all the other stuff or all the other deployments that you must be doing. You must be hosting Lambda functions, right? You must be creating certain endpoints as well in your VPC or any other application which right now you have not deployed on Kubernetes, right? So reserve those a primary CIDR for that and have a special or not special, but dedicated VPC pool, CIDR pool for your Kubernetes. And if not, you can always use open source projects available such as Flannel to have your own overlay network setup if you don't want to use VPC, right? Now, the next thing, what we can do is to have authentication enabled for kubelet as well, right? So this is important because by default, when you set up Kubernetes, you have that the communication to kubelet set as anonymous. So anyone with the Kubernetes, with the kube config access should be able to use kubelet. And once you have access to a kubelet, you can do a lot of things, right? So always, so while you're enabling RBAC, make sure that we are enabling RBAC for your kubelet as well, right? You can use that, or if not, you do not want to use it with RBAC, you can use simply our RSA token. It supports certificate-based authentication as well, so you can do that as well. But anonymous is something that we should not be doing, right? Then moving on, the next part is TD, right? Where transparent data encryption. So I just written here data at rest, but we should also be addressing data at rest as well as in transit, right? So always have your application, always have your worker nodes or on the hardware on which you're running Kubernetes encrypted, right? Although we are running on AWS again or any other cloud vendor, but it is always a shared responsibility model, right? They never say that it is going to be highly secure from their side. So it's always be going to be a secure shared responsibility model. So it's one of the best practice to have your data at rest encrypted with your own encryption key, right? Avoid using default encryption key. right? Then the second part is that we also want to protect attacks such as man in the middle, where if someone has got access to one of the namespace or one of the pod which was exposed to public, should not be able to read into the data that is passing inside the Kubernetes network, right? Even though if you're using Kubernetes service object communication, that by default it is done on an HTTP or plain text, right? So always use certain encryption methods. You can use service mesh with the MTLS, or you can have just certificate set up with your web server in which you're running your pods, right? But it's always a good practice to have both data at rest as well as transit encryption set up inside your Kubernetes cluster, right? Just like any other setup, the next point is always disable your service account, right? Disable your default service account. So if we talk about security, the first thing that always comes in your mind that whatever you get by default, you should not be using that. Always create your custom creds as well as resources, right? So wherever possible. So disable the default service account, right? Because it is created out of some convention or by default offering from the vendor. So anyone new in your organization, or anyone who has access to a network, if it is on default service account or default authentication mechanism, should be able to access it, right? Then the next point is around containers. So this is not very specific to Kubernetes, but it is something which will fit for all the container orchestration tool that you're using. Always scan your containers for vulnerabilities, right? So there should be always two types of scanning that we should be doing. Yeah, someone saying something?
No, go ahead.
All right. So talking about the container security, container scanning, right? So it is valid for all the containerized environment, whether you're using Kubernetes or even using any other container orchestration tools, right? What I suggest that we should be using containers at two levels. First is the level where you are building your image, right? The container image, right? So sometimes it's part of your CI, sometimes it's part of your CD, right? Depending upon the practice you have. So at the time of creation of your container image, once you have created it, right, you should always scan it for vulnerability, right? So that you are sure that before you are planning to deploy that container in any of the environment, you're sure around the vulnerabilities, and you can see that, hey, I don't have any critical, high or medium risk. I can go ahead and deploy it, right? The other aspect of container scanning is around when you have already deployed your containers, right? So you have already deployed your application on Kubernetes, let's say, right? And it's been running for, let's say, more than 1 month or 2 months. There were no such changes that were required in that application, right? So if you have only set up a container scanning during the time of build, you will not be able to scan drifts that is going to happen in the security that if new vulnerability has arisen, right? Now you're scanning it for the new images, but what about the images which already exist in a Kubernetes cluster, right? So there are tools in the market which helps you in doing the drift detection of security vulnerabilities as well. So we should be doing that as well, right? And based on the type of the vulnerability that we discover, we should plan our releases accordingly, fixing them, right? So we can come up with our own convention that how long I'm going to take to address critical, high, and a medium risk, right? So we should always establish that, right? The next point is that always specify a context to your pods, containers, and volumes, right? When we talk about Linux instances as well, or Linux servers as well, right? A common practice has always been that you do not run any process in your Kubernetes, any external process in Kubernetes as a root user, right? So the similar thing is true for your pods as well. These are also a process, right? No, never run your pod with root access, right? If a pod is compromised with root access, there are chances that you lose everything. Okay, so these are some good practices around security. There are many more, right? But this is something I feel that we should always be targeting whenever we are planning for security in Kubernetes cluster. Any questions till now, people?
Yeah, so Vaibhav, I have a question around the security tooling for image scanning. So which is your favorite and best recommended tool in terms of open source?
So it will be difficult for me to answer that because I'm not using right now any open source tool, right? So currently I'm the one which I would recommend that we can use if you're using AWS Cloud, you can go with ECR scans. That also gives you a very good report, right? But the tool which solves both the purpose, which I was talking about, the drift detection as well as the your container scaling, right? So there are tools like Acquia, there are tools like Laceworks, so that those tools does the job.
All right, thanks. I was using a paid tool called Prisma Cloud by Palo Alto for all this stuff. So
Okay.
that's why I asked. Thank you.
Okay. All right, then moving ahead. Okay. So the next point is resource management, right? So we talked about how about cost optimizations, right? So how do I manage my cost optimization in Kubernetes, right? So again, I'll be taking the AWS example because I have a lot of exposure on that site, right? So when you talk about cost optimization on AWS, right? So AWS gives you a very good dashboard and the cost in the costing in the billing dashboard, right, where you can find your bills happening for your each resources that you have spawned in your AWS account, right, on the hourly basis as well, right? So there are services available which can also give you recommendation based on your resources utilization as well, such as CPU, memory, and even if if it is a different type of application, maybe using a lot of network and you want recommendation on that, so you can have a custom matrices enable on that as well, right? But we do not have any such tool which gives you information around what is happening inside your Kubernetes cluster, right? So for example, I talked about that currently we are using a multi-tenant model where multiple products have multiple products have their own namespaces in which they are running application, right? So how do I add governance in that so that I can control my Slack cost, right? So what is a Slack cost? So a Slack cost is a number where you see that I have requested for the CPU or I have requested for the resources for my containers, but I'm actually not using it, right? So for example, if you have, let's say you're running an Nginx pod, right? And you have given it a resource request limit, maybe around 2 GB of RAM or 4 core of CPU, right? So if you are not doing something wrong, Nginx is never going to consume that much amount of resources, right? It will be hardly around some MBs and some millicodes, right? So the rest of the memory which is left, right, around your resource configuration is your Slack cost, right? While AWS can show you that, hey, your EC2 instance seems to be costly, you can move it to T2 micro, right? Because it does not show any resource utilization. But when you look at your Kubernetes cluster, you are saying that you've already requested 90% of your cluster resources, right? So these are some metrics to look at that, hey, what am I requesting and what am I using, right? So to get more clarity on your resources, there are some good practices that we can follow, right? So the first one is that always add a request and limit for your containers, right? Do not run your containers without boundary, right? Because if there is a memory leak or maybe a thread leak, right? So thread not being closed, right? So you will see that it is overshooting your request. And then you will also end up in a situation where you are, where you will see there's a noisy neighbor concept where you'll see that your actual application, which is running right, has started showing some errors, right? Because the other application had some resource leaks, but it was not limited by some boundary, right? So always configure your containers with the request as well as in the limits, right? Request again will help you with not just running it in a confined way, but also managing your resources in a way that, let's say, if you do not have enough resources in your Kubernetes cluster, right, then your pod will go in pending state, and then your cluster autoscaler can add another node to have it placed, right? So both request and limit are important. Always said that, right? Now create a separate namespace for your team/products, right? So if you are running a multi-tenant model or you're planning to do it, always have this control enabled and have RBAC associated with it, right? So that once you have set up the cluster, you have given to a product team, they can also operate with some autonomy, right? So always have that control enabled. and have some resource quota also assigned to a namespace. So just like we control our cost in our cloud, we can also control it in Kubernetes, when we can have a provision for our teams or tenants to request for resource quota, right? So they can define that, hey, I'm going to use around 4 core or let's say 8 core of CPU and 16 GB of RAM for all my app microservices that I'm going to run, right? So if something is shooting, then we need to first look at it, that if it is an actual reason or something has went wrong, right? And if it is not an actual reason, we can always go back and increase it. And if there is some issue that has happened, we should always be fixing it. But we should not be leaving it like this, that it's an infinite scaling that you can do in your Kubernetes cluster, right? Then the next thing is that to attach labels and Kubernetes objects, right? So this is very essential, not just for resource management, but for a lot of things, right? If you are creating certain policies, if you're creating certain maybe custom resources also, or for the resource management specifically, you will have always find labels handy, right? Based on which, because labels will give you some logic to where you can do the filtering of your object and see how the resource utilization or how your application is performing, right? So these, so for example, let's say I want to check that for my product 1, what is the resource utilization I'm seeing, right? So if I have made a practice that for every microservices I'm deploying in for product 1, I'm attaching a label with as product name : product 1, right? So I can simply use that filter to find out the number of resources that are running, and also can find out if there is some exceptions happening there as well, right? So always run your Kubernetes objects with a label, right? Limit the number of pods that can run on a node, right? So this is also important. So it may happen while you're early adopter that your request and limits are like way long, right? So you start with 256 millicore or 256 MB of RAM, and you have given your limit to as 4 GB of RAM, right? So if you do that, it will always go, it will always going to happen, since you're requesting a lot less, your pod will get placed, right? But as soon as you start putting load, you will see that you're not able to get the same performance, right? Also, your node also has some limitation on the number of resources it can support, right? So it has a limitation on the number of Ethernet it can support. It has a limitation on the bandwidth as well as your CPU and memory, right? So based on your product, you should also look at that whether limiting the number of pods, the maximum pod that I can run, should benefit or not, right? The other thing that we need to keep in mind, that while we are working on deploying our product or our custom application in Kubernetes, we forget about certain daemon set that we have already spawned, right? You might have been running Prometheus, you might be running any other daemon set, right? For your logging, scrappers and whatnot, right? And that is something that you have already booted up in the cluster, and it's already running on all nodes, right? So when you're planning to run another pod in your cluster, always consider the number of daemon sets which are already running. And based on that, take a call that what should be the right request or limit, and whether that particular node can suffice your request or not, right? So if not, you might also think of beefing up the size of your worker node as well, if that is happening, right? Then the next point is configure out of resource handling, right? So it may happen, like I said, scenarios that specifically while you're running performance tests, that you had configured your cluster with your proper limits, you have limited your nodes, but still you're seeing certain things going out of resource, maybe a pod spiking up, right? So have some custom matrices based on your application, on which you are scaling it up, on which if certain pods are going out of your out of the limited out of the requested value, or some exception happening over there, have some custom matrices and events on which you're listening, and based on that you're taking that call whether it is a right event or wrong, right? So you can do that. The next point is enable log rotation. So again, this is something not very specific to Kubernetes, right? It is one of the good practice. Whatever software, whatever application you're installing on any server, always have log rotation enabled, right? You can have it you can just do the archives, or if you require the log for a longer time, or simply just delete it if you do not require it. So always have the log rotation enabled for your application. All right, any questions? moving on, monitoring and alerting. So till now, we talked about that how we should configure your application for availability, for scalability, for high performance, and for resource management, right? But still now we just talked about that, hey, how if I'm planning to deploy my application, these are the things that I should be doing to make sure that my application is able to take the load as well as scale as well, right? But monitoring and alerting is also as important part of your architecture pillar as any other pillar which talks about scalability, availability, and rest of the other stuff, right? We need to observe, we should have a tooling in place which is able to give you what is happening inside your cluster without you being required to log inside it, right? Try to avoid as much as you can to log inside your pods and see what exactly is happening, right? Have the monitoring pipeline set up, which is extracting your logs as well as your matrices, which are essential for you to look at what has happened inside the pod, right? From outside, from your monitoring dashboards, right? There are market standard industries acceptable tools such as Prometheus and Grafana does the job amazingly. You can have Elasticsearch configured as well for your string-based logs as well, right? If those are not matrices, right? So always try to have those kind of monitoring pipelines set up where you do not require for a developer or for an SRE to log in inside your pods to look at what exactly has happened. Okay. Then they select a list of metrics / logs to monitor, right? So there are certain good practices which is like applicable to all, but then there are certain matrices or logs that will be essential depending upon your application, right? So it may happen that your application is more around IO intensive or have more disk operation than CPU and memory, right? It is not doing that. Maybe it's a distributed application, just taking the event from one queue and sending it to another queue, right? So it's not consuming much of your resources, but you still see there is maybe a plateau that you hit, that you're not able to scale or gain the performance that you expected as you increased your load, right? Because you're seeing that it's a very simple application. It's just picking the metric from putting the event from one queue and putting it to another queue, not doing much, right? You're not seeing any CPU and memory, right? So depending upon your application, you need to find out what exactly is the resource it is consuming, and you need to select those matrices, and you need to have your monitor configured to watch that, right? You can also create matrices on top of your logs as well, right? So even now Elasticsearch provide, if you're using AWS, CloudWatch has already had this feature for around, I think 2-3 years, where you can configure your custom metric on the basis of your logs. So always look for that and have your cluster configured, have your monitor configured to observe that, right? And on top of it, Prometheus comes with, and there are with support of alert manager as well, and there are many other tools as well which we can use, right? So always have some alerting tool as well, so that if some event happens at night, right, so you are getting a call on your cell phone and you're don't have to look at your email, right? You don't have to depend on your email to check if something has happened, right? So if you're using Alert Manager, it has integration with PagerDuty, it has integration with VectorOps, which is one of the best tools that I personally find, right? So you can use those tools, right? And you can have those configured to send you the notification if something has went wrong on your cell phone, and you're able to debug it, right? So, and just for the start of your debugging, you should also have these monitor boards set up for you to give you a consolidated view, what exactly is the state of my cluster, and to flag out which services has been not performing really well, right? So this is what you can do. Any questions till now? All right, so this is it from my side. I have put some references as well. One of us is on my own blog, where I have consolidated a lot of data from different rest of the blog, which you see in here, right? But there are many more blogs which you can find out, and I hope this will be helpful for you to configure your Kubernetes cluster, right? And yeah, we can always connect if you need anything. Thank you so much.
Cool. Hey, thank you so much, Vaibhav. That was a very insightful session.
Yeah, thank you. Thank you, Vishal.
Cool. All right. Thank you everyone for making it. And we usually do like once a month, meetup on topics. We're also looking for speakers, any case studies, interesting ideas. So please feel free to reach out on Twitter or just message me on Kubernetes Pune meetup group. All right. Thank you everyone. Have a great rest of the weekend and see you around next time.
Thanks everyone. Thanks for wonderful session.
Thank you.
Thanks, everyone.
Thank you.